Educator.com. In previous lessons, we talked about solving quadratic equations through factoring and through graphing. Today, we're going to learn another method called completing the square. And you may have learned this earlier on in Algebra 1, so it may be review. And if you need even more depth, you can look at the Algebra 1 series here at Educator.com. Now, recall that some quadratic equations can be solved by taking the square root of both sides of the equation. And this includes equations where the quadratic expression is a perfect square. So, for example, if you have x squared minus 8x plus 16 equals 5, you may recognize that this is a perfect square, this trinomial. It's a perfect square trinomial. It's actually equal to x minus 4 squared, or x minus 4 times x minus 4. So if I put this in this form and write it as x minus 4 squared equals 5, I can then solve it by taking the square root of both sides. So take the square root of both sides to get x. So take the square root of both sides of the equation to get x minus 4 equals plus or minus the square root of negative 5. And recall that you need to take both the positive and negative square root of 5, because thinking back, if you had something such as x squared equals 4 and you were to take the square root of both sides, that would give you x could equal 2 or x could equal negative 2, because 2 squared equals 4 and negative 2 squared equals 4. So it's the same concept here. It looks more complex, but it's the same concept. On the left, I'm taking the square root, and then on the right, I'm taking the square root of a number, and it could be both positive square root of 5 or the negative, whatever the square root of 5 turns out to be. And I can't simplify that any further because without a calculator, I can just leave it in this form, plus or minus the square root of 5. I can't, since this is an irrational number, I can't get an exact value. I just need to leave it in this format. Okay, so this is going to give me x equals 4 plus or minus the square root of 5. And I could put this in this form. I could leave it, or I could say x equals 4 plus the square root of 5 and x equals 4 minus the square root of 5. These are both solutions to this quadratic equation. Now, how do you recognize perfect squares? If you have a perfect square trinomial, and it's in the form ax squared plus bx plus c, then what you can do is realize that the constant equals b divided by 2 squared. Or sometimes we do just say it's b squared over 4. So if you're looking and you're not sure if it's a perfect square trinomial, look at the constant term. And here I have a equals 1 for a coefficient, b equals negative 8, and c equals 16. So what I want to do is I want to see if b squared over 4 equals 16. And if I look, I say, okay, that's negative 8 squared over 4. And that equals 64 divided by 4, which is 16. So this checks out. So if you're not sure if you have a perfect square trinomial, you can just look at the constant. If the rest of it checks out as perfect squares, and then you're not sure, then you can check and say, okay, does the constant equal b squared over 4? Yes, it does. So I knew I had a perfect square trinomial, and that makes it easy to find the square root of both sides and finding the two solutions for this quadratic equation. Okay, sometimes you don't have a perfect square trinomial. In that case, what you can do is actually complete the square. You can make it into a perfect square. Now, what I just said is that the constant term in a perfect square trinomial equals b over 2 squared, or I like to just use it as b squared over 4, but it's the same thing either way. So, for example, let's say I'm given 8x squared minus 8x. Okay, similar to the last, but that was already a perfect square. So I'm just given this portion, and I want to I want to complete the square. So in order to complete the square, what I need is a constant term. And I know that in a perfect square trinomial, the constant is going to equal b squared over 4. So really what I'm looking for is this. Okay, here a equals 1, b equals negative 8. Therefore, I have x squared minus 8x plus negative 8 squared over 4. X squared minus 8x plus 8 times 8, that's 64 over 4, to get x squared minus 8x plus 16. And now I have a perfect square trinomial. So last time I talked about if you had something and you thought it was a perfect square trinomial, you can check it out by seeing if the constant is equal to this. Conversely, if you don't have a perfect square, you need to complete the square. You just have this part and you want to get the constant term to complete the square. You can use this knowledge to find what that constant should be, and then from there we can solve equations. Now, to solve any quadratic equation, you can complete the square by adding this, which is equal to b squared over 4, to both sides of the equation. In the last slide, I talked about completing the square. But if you have an equation, you need to keep the equation balanced, so you can't just complete the square and then do nothing to the other side. So let's take an example here, slightly different than the other one, but related. This time, x squared plus 6x plus 8 equals 0. So now I have an equation. Now, the first thing to do is, if you're dealing with an equation, get the constants on one side. So I'm going to get the constants on the right, because I want to clear out and just have these x variable terms here on the left, so I can complete the square on that. I'm going to subtract 8 from both sides. To get x squared plus 6x equals negative 8. Now, I want to complete the square. And I know that to complete the square, I'm going to need x squared plus 6x, but I need a constant term. And the constant term is going to be b squared over 4. Now, I have to add to both sides. Add b squared over 4 to both sides. This is a step that sometimes gets forgotten, and then you get an incorrect answer. Okay, so this is going to give me x squared plus 6x plus, well, b is 6. Now I have to add that over here as well. Okay. This is going to give me 36 divided by 4, which comes out to 9. So coming up here, x squared plus 6x plus 9 equals negative 8 plus 9. Or x squared plus 6x plus 9 equals 1. Now I have a perfect square trinomial. And I can go and use techniques used previously in order to solve this, such as a zero product, taking the square root of both sides. X plus 3 squared is the same as this trinomial, equals 1. Now, we take the square root of both sides to solve this to get x plus 3 equals plus or minus the square root of 1. So, the square root of 1 is 1, so I get x plus 3 equals plus or minus 1. From there, you can just solve. I get x plus 3 equals 1, So x equals negative 3 plus 1, x equals negative 2. And I also have x plus 3 equals negative 1. Therefore, I'm going to get x equals negative 4. Okay, so really focusing just on these first steps, but to finish it out, what you ended up with is x equals negative 2 and x equals negative 4 as the solutions. To solve a quadratic equation when you don't already have a perfect square trinomial involved, get the constants on the right and the variables on the left. Then complete the square by adding b squared over 4 to both sides. Once you've done that, you've got a perfect square here on the left. Turn this into this form, and then take the square root of both sides to get your solutions. Okay, sometimes the coefficient of x squared, the leading coefficient is not 1. So far we've been working with situations where we just had x squared. If the coefficient is not 1, you need to take an extra step, and you need to divide both sides of the equation by the coefficient in front of the x squared term in order to make that coefficient 1. Then you just go on and complete the square as usual. For example, if I was given 2x squared minus 12x plus 4 equals 0, I need to make this coefficient 1. So I can do that by dividing both sides by 2. And that's going to cancel out right here to give me x squared minus 6x plus 2 equals 0. Okay, now I'm going to go ahead and complete the square. Remember that my first step is to get the x variables on the left, and I'm going to subtract 2 from both sides to get the constants on the right. Then I need to complete the square. X squared minus 6x, so I need to now add b squared over 4 to both sides to complete the square. So this is x squared minus 6x plus b squared over 4 equals negative 2 plus b squared over 4. Okay, x squared minus 6x, well, b is negative 6, so that's plus negative 6 squared over 4 equals negative 2 plus negative 6 squared over 4. This gives me x squared minus 6x. This is 36 divided by 4. So I'm just going to simplify that to 9. And if I had not added to both sides, the equation would not be balanced, and I would not get the correct solutions. Okay, coming up here to get x squared minus 6x plus 9 equals 7. Well, now I have a perfect square trinomial, which is actually x minus 3, because this is a negative right here, squared equals 7. Remember, take the square root of both sides to get x minus 3 equals plus or minus the square root of 7. Isolate the x to get x equals 3 plus or minus the square root of 7. So the two solutions are x equals 3 plus radical 7, x equals 3 minus radical 7. Okay, so same as what we just did with completing the square and then taking the square root of both sides, but with an extra step, because in order to complete the square, you need for the coefficient of x to be 1. If it is not 1, if you have a leading coefficient that is not 1, begin by dividing both sides by that coefficient. Okay. Sometimes the solutions to a quadratic equation may be complex numbers. Just to review, complex numbers consist of a real part and an imaginary part, something such as 3 plus 2i. So this is in the form a plus bi, where a is the real part and 2i is the imaginary part. It turns out that for quadratic equations, solutions may end up in this form. Let's look at a situation where that could occur. Let's say I'm given x squared plus 2x plus 10 equals 0. And I'm going to solve this by completing the square. So first, I'm going to isolate these x variables on the left and the constants on the right by subtracting 10 from both sides. Now, I need to complete the square. Okay. So I want to add b squared over 4 to both sides of this equation. Well, b is 2, so that's going to give me 2 squared over 4 equals negative 10 plus 2 squared over 4. So this is x squared plus 2x. Well, 2 times 2 is 4. Divided by 4, that's just 1. So this is negative 10 plus 1. This gives me x squared plus 2x plus 1 equals negative 9. Okay, so I now have a perfect square trinomial. And because I have that, I'll just go ahead my usual way and take the square root of both sides. So let's come up here and finish this. Take the square root of both sides. Let me rewrite it. So this is a perfect square. It's x plus 1 squared equals negative 9. Square root of both sides gives me x plus 1 equals the square root of negative 9. Now, before learning about complex numbers, we would have had to stop here and say, okay, this is undefined. There's no real number solution. We don't know what to do with this. But now that we've discussed imaginary numbers, we do know what to do with this. So let's look at how we can handle this. We know that this equals negative 1, radical negative 1 times 9. And remember, the positive and negative results for this. So you need to take both, plus or minus the square root of negative 9. Okay. Using the product property, this is going to equal this. Recall that with complex numbers, the square root of negative 1 is equal to I. Okay, so this is going to give me x plus 1 equals plus or minus I times the square root of 9, which is 3. Therefore, now this is something I can work with. X equals, I'm going to subtract negative 1 plus or minus 3i. All right, so here we saw a situation where the solution to a quadratic equation is a complex number. And the reason is you're taking the square roots. When you're taking the square roots, if you end up with a negative number and you take the square root of that, you're going to get an imaginary number. So here I got all the way down by my usual method, completing the square, then taking the square root of both sides, and I ended up with this. But I recognize that this square root of negative 9 is equal to 3i. So then I could simply say that my solutions are x equals negative 1 plus 3i and x equals negative 1 minus 3i. And that's a set of complex conjugates. Okay. So let's use the square root property to solve this. And I'm recognizing that this is a perfect square trinomial. So I don't have to complete the square. It's already done for me. So since this is negative here, this is x minus 3 squared equals 7. And if I take the square root of both sides, I'm going to get x minus 3 equals plus or minus the square root of 7. So x equals 3 plus or minus the square root of 7. Or you could write this out as x equals 3 plus radical 7 and x equals 3 minus radical 7 as the solutions. So when it's already a perfect square trinomial, it's much easier. In this example, I'm going to have to complete the square. And this is just asking me to complete the square of x squared minus 10x. So in order to do that, I need a constant. And for a perfect square trinomial, the constant is going to equal b squared over 4. So that's x squared minus 10x plus b squared over 4. And since this is in standard form, that's ax squared plus bx plus c. That means that b equals negative 10. So x squared minus 10x plus negative 10 squared, all divided by 4. Okay, So x squared minus 10x plus negative 10 squared is 100 divided by 4. X squared minus 10x plus 25. This is a perfect square. This is the same as x minus 5 squared. Okay, so to complete the square, you need to find a constant term, and the constant term is going to be equal to b squared over 4. So b equals negative 10, substituting in here, and that gave me a perfect square trinomial. Solve by completing the square. The first step is to isolate the x variables on the left side of the equation. So subtract 12 from both sides. Then complete the square by adding b squared over 4 to both sides. And it's very important that you do this to both sides to keep the equation balanced. Okay, so b is 6, so this gives me x squared plus 6x plus 6 squared over 4 equals negative 12 plus 6 squared over 4, which is 36 divided by 4. $36 divided by 4 is just 9. Okay, simplifying a bit more on the right. Okay, now I have my perfect square trinomial on the left. So I'm going to come up here and just rewrite that because I was asked to do more than just complete the square. I actually have to solve the equation. So now I'm going to write this as x plus 3 squared equals negative 3. In order to solve this, I'm going to take the square root of both sides. So x plus 3 equals plus or minus the square root of negative 3. From previous lessons, I know that I can change this to negative 1 times square root of 3. And recall that the square root of negative 1, I is equal to the square root of negative 1. So this is I radical 3. Okay. So this gives me x equals negative 3 plus or minus I radical 3. Or I could write it out, x equals negative 3 plus I radical 3, and x equals, these are both solutions. They're not real solutions, real number solutions, but they are solutions. So solving by completing the square, isolating the x variables on the left, the x variable terms on the left, and the constants on the right. Adding b squared over 4 to both sides gave me a perfect square trinomial on the left, which was x plus 3 squared, and negative 3 on the right. Solving by taking the square root of both sides gave me this. I then simplified this, since square root of negative 1 is I, into I radical 3, and then isolated x to get x equals negative 3 plus I radical 3, x equals negative 3 minus I radical 3. Okay, again, we're going to solve by completing the square, and my first step is always to get the the variable terms on the left, the constants on the right. Then complete the square. Subtract 18 from both sides. Now, here, before I go any farther, I've got to look and see that my x term is not 1. My x squared term is not 1. So if x squared coefficient, if the coefficient of x squared is not 1, divide both sides of the equation. And the reason is I need to do that in order to complete the square and go on as usual. So I'm going to divide both sides here. And I could have done it up here, but it's easier to do it at this point when I'm simplified a bit. I'm going to divide both sides by 3. These cancel out, and now my x squared coefficient is 1. 12 divided by 3, that gives me negative 4x. And 6 divided by 3 is 2. Now I can go about completing the square. Because my leading coefficient is 1. Doing that by adding b squared over 4 to both sides. b is negative 4. So this gives me x squared minus 4x. And this is, 4 times 4 is 16 divided by 4. So that's just 4. And this is also going to be 4. Okay. So coming up here to finish, this is going to give me x squared minus 4x plus 4 equals 6. I now have my perfect square trinomial here, and it's x minus 2 squared. It's a negative 2 because the middle term's negative. And I'm going to find the square root of both sides. So x equals 2 plus or minus the square root of 6. So this problem took an extra step. After isolating my variables on the left and my constants on the right, I saw that my leading coefficient was not 1, so I had to divide both sides of the equation by that coefficient 3. Once I was there, then I went about completing the square by adding this term to both sides, getting a perfect square trinomial, which is this, and taking the square root of both sides to get my solutions. Thanks for visiting educator.com, and I will see you for the next lesson.